Okay, welcome to the final finite lesson of 2020, 2019, 2020. You guys have done a heck of a job surviving e-learning. I don't know in your place that I would have been able to do anywhere near as well as some of you did. Um, be gritty, be persistent. Let's finish this thing strong. So we're talking about the last lesson in the networking graph theory unit, which is covering what are called Steiner networks. And to do that, we're going to talk about a telecommunications system in the middle of the desert. Okay, so in that desert there are three towers: Tower A, Tower B, and Tower C. Those towers are built in an equilateral triangular shape with 500 miles between each of those towers, and they're doing that to cover as much distance as they can. But they decide that they can get a stronger connection, a stronger Wi-Fi connection for their network if they run a wired connection between these three towers. Okay, so they need to build a network between these three towers. Okay, now here's the problem. The problem is if they use the minimum spanning tree, then the shortest distance they can come up with to connect those 3 points would be the minimum spanning tree. Okay, so the minimum spanning tree is 100 miles long. They need to run 100 miles of cable to use the minimum spanning tree for their system. But it takes engineers about 10 seconds to notice that they could do this with far less wiring. If instead of doing the minimum spanning tree, if instead they did something along these lines. Okay, just by doing what they would call a T network, they've managed to reduce the length of cable that they need to be only 933 miles of cable. Now, 67 miles of cable is going to make a significant difference in the amount of wiring and the cost overall of building this network. Okay, so almost guaranteed they would rather build that network there along the altitude of the triangle than use the minimum spanning tree, because 67 miles of data cable is a lot of cost. It's thousands and thousands and thousands of dollars. Well, there's actually a form of mathematics coined by a mathematician whose last name should not surprisingly be Steiner, that says that somewhere on that altitude there is a point that actually represents the shortest distance. If you connect that point to the three vertices of the triangle, it guarantees the shortest distance between the 3 points in certain situations. So the Steiner point would be located in this particular triangle. It would be located at the center of rotation because it's an equilateral triangle. Okay, 1,000 should be 1,000. You're right, 1,000 miles. Sorry. Okay, so we got the minimum spanning tree is 1,000 miles. The T network is 933 miles. But this Steiner point, if it's connected to all three vertices of the triangle, that distance from the Steiner point to your three vertices is known as the Steiner network. And using some trigonometry, we can figure out that that distance is the minimum distance, which is 866 miles. Okay, 866 miles. Now, where is that coming from? Well, it has to do with Pythagorean theorem. And there's quite a bit of math involved, and there's a law of cosines. But essentially what it boils down to here is that all three of these angles in here around the Steiner point, each of those angles is 120 degrees. And this is all explanation. This is not something you're going to have to do on your own. So using some math, we can figure out the length of one of these legs. Okay, you can run the law of cosines. We can figure out the length of that leg because we know the 120 degree angle. We know the 500, and we know that the other two sides are the same length in this case. Now they're not always the same length, but they are in this case. Okay, so we can run some math. We can figure out that that network is 866 miles, and in fact, this is the shortest distance between those 3 points. Through the Steiner network. So what this boils down to is it's going to boil down to figuring out when the minimum spanning tree is the shortest distance and when the Steiner network is the shortest distance between those 3 points. That's what we've got to be able to do today. Okay? That's the question. You know, what is the shortest distance? It's either going to be the minimum spanning tree or it's going to be the Steiner network. It's never going to be anything else. And it's very, very simple to tell the difference between the two. So we're going to go over how to tell the difference between the two on the next screen here, and then we're going to do some example problems. Now these example problems require trigonometry. They require a certain knowledge of geometry that we've already established in our course. There's nothing to this lesson that we have not previously done this school year, but some of the stuff happened a while ago. So there's going to be some reaching here. There's going to be some remembering. So I hope that nobody has pulled the, oh, I'm logged into the Zoom session so I can wander away from my screen and not listen for the rest of class trick, which I'm sure some of you have. I would suggest that you change your tune here and pay close attention, especially to the next page, and then the examples, of course. So take your screenshot if you want it. We're going to move on to the next screen. Okay, so the shortest distance between 3 points. Okay, the shortest distance between 3 points is through the Steiner point if the largest angle in the triangle formed by those 3 points is less than or equal to 120 degrees. And the shortest distance between the 3 points is the minimum spanning tree, or MST, if the largest angle in that triangle is greater than 120 degrees. So that's what it boils down to. We need to know the measure of the largest angle. Okay, that's the key. We have to find the measure of the largest angle formed by those 3 points. Okay, and we do already know how to do that. Sometimes it's going to be really easy, and sometimes it's going to require law of cosines and be not so easy. But what it boils down to is this rule right here. The Steiner point, we look at the largest angle. The Steiner point, the Steiner network, is the best answer if the largest angle is less than or equal to 120 degrees, and the minimum spanning tree is the shortest distance if the largest angle is greater than 120 degrees. So 120 degrees is our tipping point between the two things. If it's less than or equal to 120, the largest angle, then it's a Steiner network. If it's greater than 120, then it's a minimum spanning tree. Again, grab a screenshot if you want one, then we're going to go do a couple of examples. Okay, so Is the shortest network connecting cities A, B, and C a minimum spanning tree or through a Steiner point? Now notice that this is not an equilateral triangle, so it is different from the first example that we looked at. We've got these three side lengths in our triangle, 3,910 miles, 3,820 miles, and 1,620 miles. So we should know from geometry right away which angle is the biggest angle. It should be relatively simple for us to figure out which angle is the biggest angle, because the biggest angle is always opposite the longest side. Which means that the largest angle is angle A. This angle is the key. It's the one that we need to find the value of. Now, I decided to go with the hardest example first because I know that sometimes you guys lose steam. So in this case, we need a way to find an unknown angle when we know three side lengths. We did that back in trigonometry. That requires the law of cosines to do. Specifically, we need the version that puts angle A into the equation, okay? Remember that this would be little a, this would be little b, this would be little c. And our equation would say a squared equals b squared plus c squared minus 2bc cosine of angle A. That is the law of cosines. Now this is going to get worse before it gets better because we have to plug in everything that we know and then solve for angle A. Okay? So little a is 3,910. Little b is 3,820. Little c is 1,620. So we plug those in, and that gives us that equation. Now, we need to solve that equation for A. So if you remember, when we did these problems, there's certain things we can plug into the calculator all at one time, and there's things we can't. So the three things I've underlined in red are going to get fed to the calculator separately. Okay, 3,910 squared is a really big number. Okay, so we have, what is happening? It's not what I want. Tech issues, stand by. Okay, so we feed that to the calculator. That would be 15,288,100. And then we feed that next section to the calculator. I'll go ahead and leave the stuff I'm not putting in the calculator in blue. So 3820 squared plus 1620 squared. I'm going to feed all that to the calculator at one time. And that is 17,216,800. And then we've got minus, and we're going to feed that next section 2 times 3820 times 1620 to the calculator, which is 12,376,800 times the cosine of angle A. Okay. Now, what we've got there, again, we need to isolate cosine of A. We need to get it by itself so that we can solve by taking the inverse cosine. So our next step in this process would be to subtract 17,216,800 800 from each side. That would give us 288, 100 minus 17, 216, 800 negative, which is possible, 190 or 1,928,700 equals negative 12,376,800 cosine of angle A. Now, to get cosine of angle A by itself, we then need to divide each side by negative 12,376,800. Which is going to give us a decimal. That gives us, and keep the entire decimal, okay, 8,31879 is what my calculator shows, is equal to the cosine of angle A. And then our final step, remember that anytime we need to get rid of a cosine, we take the inverse cosine. So we're going to take the inverse cosine, second cosine on your calculators, of that decimal, which gives us an angle A is roughly 81.03 degrees. Okay? Now that is the biggest angle in this triangle. So that is what we need to know in order to answer this question. Because if that angle, the biggest angle in the triangle, is less than or equal to 120 degrees, then that means our answer is that this is through the Steiner point. Okay? So since the measure of angle A is less than 120 degrees, that means the shortest distance between these 3 points is the Steiner network, which is the network that passes through that Steiner point. Okay? Now we did the hard example first. That is by far harder than what you're normally going to have to do. I think I put 2 law of cosines problems on the homework out of, I think, 7 questions. 2 of them require the law of cosines. The other 5 will be much easier. Okay, so this is the way we approach that problem. Both of those problems will fit this sort of description. You'll need to run a law of cosines and work your way backwards to that largest angle so that you can figure out whether it's through the Steiner network or the minimum spanning tree. Okay, funny story. You won't have to. Okay, you won't have to put that in there. Is it? Am I not coming through? Yeah, I am. I think I am. Okay, so you're gonna have 2 of those on your homework, law of cosines problems. You're gonna have to solve that on your own. There'll be a box for you to explain your work. You won't have to type all of that in. Pretty much what you can say is, I used the law of cosines. I found the largest angle is this. That angle's less than 120, which means it was a Steiner network, something along those lines. Okay. All right, take your screenshot if you want one. We're going to continue to the next example. We have 2 examples to go. They're much easier examples than this one. I want to show you several of the easy ones as well, because 5 of the 7 on your homework assignment will be the easier problem types. All right, so here's the next example. Same directions. Is the shortest distance between these 3 points the minimum spanning tree or a Steiner network? Now, I won't necessarily need to see that work separately. No, you can just, I'll take your word for it that you did that work. Okay. So here, we don't need to use the law of cosines. We just need to figure out the largest angle in the triangle. We have to do whatever we have to do to find the largest angle in the triangle. Now, we already know 2 of the 3 angles. So everybody in here should know how to find the 3rd angle. How do we find the 3rd angle if we know 2? Well, the angles in any triangle add up to 180 degrees. Okay? So the measure of angle E plus the measure of angle D plus the measure of angle F has to be 180 degrees. It's a triangle. Okay? You're welcome to send your work to me separately if it makes you feel better. I'm fine with that. I'll look it over if I need to. So we plug in what we know here. The measure of angle E plus 22 degrees plus 37 degrees equals 180 degrees. And that's a pretty simple equation to solve. We combine like terms. 22 plus 37 is 59 degrees. And then we subtract 59 from each side to figure out the measure of angle E. So the measure of angle E would be 121 degrees. Okay? All right, now once we know that, that is the largest angle in the triangle is angle E, which is the only one we really care about, is the largest angle. Okay? And if that largest angle is greater than 120 degrees, that means the minimum network is the minimum spanning tree. Okay, what it boils down to is we need to find the biggest angle, and then if it's more than 120, it's the minimum spanning tree. If it's less than or equal to 120, it's the Steiner network. Okay, that's what I'm asking you to do tonight, is identify the shortest distance. Is it this minimum spanning tree or is it the Steiner network? Okay, that problem is done. So grab your screenshot if you want one. We're going to do another easy one. And then we will call it a day because I've already been talking for almost half an hour and some of you have already tuned me out. The law of cosines problems will be identifiable because instead of giving you angle measures, I will give you all 3 sides and no angles. That's the law of cosines problem. Okay? There will be 7 questions on the homework. 2 are law of cosines. 5 will simply require you to remember some basic geometry. Muha. Muha ha 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 ha. Since I taught most of you geometry, I get to do the evil finger pyramid of evilness about some of those questions. Okay? All right. I just tried to use my mouse to scroll my iPad down. It's been that kind of week, folks. All right, last question. Okay, same deal. We need to find the measure of angle X, okay? The measure of angle X plus the measure of angle Y plus the measure of angle Z. It's a triangle, so they have to add up to 180 degrees. That's one of our basic geometry rules, right? It's not that many. Come on, 7 problems. 5 of them are this easy. You'll be fine. Okay, so we plug in what we know. The measure of angle X plus 38 plus 24 equals 180 degrees. Add the 38 and the 24 together to get 62. Subtract 62 from each side. And we get the measure of angle X is 118 degrees. So there's our largest angle, is 118 degrees. Since that is less than or equal to 120 degrees, that means our minimum network will be through the Steiner point. It will be the Steiner network. Okay, so it's that simple. We find the biggest angle. If that angle is less than or equal to 120, then it is the Steiner network. And if it is greater than 120, it is the minimum spanning tree. Okay? Yes, you are always looking for the largest angle in the triangle. And there's a couple problems on the homework where I give you the largest angle. And if you recognize that, the problem will take about 5 seconds to do. Okay? But again, there's going to be some basic geometry we need to remember. For instance, the largest angle in a triangle, if you've got an angle that's 90 degrees or more, that is the largest angle, right? Should remember that from geometry. Yes, no, well, probably. No, it's been a while for some of you. Okay, if you have questions, don't be afraid to email me those questions while you're working on it. I'm sitting here all day. Okay, I can answer questions. That does it for our lesson today.